Hi, today's session is around GraphQL and Neo4j, simple and intelligent modern apps. So it's about the combination of GraphQL framework for API and Neo4j to build applications in shorter time to value cycles with the help of the Neo4j GraphQL library, which is low code, secure, flexible, and developer friendly. One quotation is from Lee Byron, a GraphQL co-inventor, think in graphs, not endpoints. And this is from 4 years learning with GraphQL. And I think that GraphQL is really about accessing your data through API as if it were a graph. And another quotation from me in lessons from 4 years of Neo4j, everything is a graph. So when you are in a connected world, you tend to think about connected things as a graph. So there is a logic that GraphQL and the graph database Neo4j go together. Let me introduce myself. I am Nicolas Rouyer, a sales engineer at Neo4j. It's been 4 years. I like stickers, as you can see on my laptop. I'm also a violinist, and you can reach out to me at nico@neo4j.com. Everything is a graph for me. So, for example, I'm fond of the combination of Neo4j, which is a graph database, and of GraphQL, which is um, an API framework to expose data as a graph. And so everything is a graph, even the logic of presenting Neo4j and GraphQL together. Let's have a quick recap of what is Neo4j. With two use cases, one from AstraZeneca that uncovers new molecular relationships in enormous data sets by building a knowledge graph. And this was something difficult to gather all those sources of data together and get some value from them. And Caterpillar is also a well-known Neo4j customer that unlocks insights from equipment repair and maintenance across tens of millions of technical documents. And this also was an enormous challenge for Caterpillar. What do they have in common? Well, it's about data meeting graph because the graph structure makes it more intuitive to look at your data. It gives you a connected view of the data through relationships. And this unlocks deeper understanding of the world, deeper understanding on the context. We say at Neo4j that we value relationships. The value lies in relationships, not only in data, relationships between data. And for this, we use the property graph, which is very simple and very powerful. So the property graph here, we understand it visually. An employee works at a company located in a city. Well, we have nodes that can have 0 or more labels. Those nodes represent entities, employee, company, city, and nodes can have any number of properties that are key value pairs. The relationships, they connect nodes, and they are typically verbs. So we have a subject, predicate, and an object. And the relationships can have any number of properties, key value pairs, like nodes. And relationships are always directional, but they can be queried in either direction. But the direction is always stored in Neo4j. So by the time you have a model that you describe it in a whiteboard, you are able to store it. There is no discrepancy between the conceptual model and the physical model. They are the same in Neo4j. We store data as nodes and relationships. And some analysts like Gartner and Forrester say that by 2025, a graph will be used in 80% of data and analytics innovations. The use cases that are typically graph are around real-time recommendations, fraud detection, network and IT operations, master data management, risk and compliance, and IAM, identity and access management. So Neo4j is the first ever graph database. Neo4j is creator of the market category and a continued market leader with 300 plus 1 billion plus enterprise customers, more than $500 million in funding, and especially the biggest funding in database world 2 years ago of $350 million. We have a huge ecosystem of partners and a massive community of developers and more than 100 million plus downloads. And that's it for Neo4j. And now Neo4j will be in combination with GraphQL through the Neo4j GraphQL library. So GraphQL is a syntax to query data as a graph. We describe our data with type definitions. We ask for what we want, and each time we want something more, and we want to traverse the data to get more data connected, we open a bracket, and yeah, it's like following a relationship in a graph, and we get predictable results. So GraphQL is generally used to download server data to client, and it has three main features. It allows client to ask exactly for the data it needs. It facilitates the aggregation of data from multiple sources, and it uses a system of types to describe the data. The most valuable set of GraphQL with regards when compared to REST is that there is no more over or under fetching. With one and only one GraphQL HTTP request, you can ask for any data that is in your database. The @Neo4j GraphQL library is a kind of translation library. It converts a client request into Cypher code, which is Neo4j language to traverse data through pattern matching. The library uses type definitions and is low code or even zero code, because you can use a feature named introspector to generate a GraphQL schema from your graph model in the graph database. It means that in a three-tier architecture, a GraphQL client will send HTTP requests with a payload that is a JSON payload, and this JSON payload will be translated in Cypher to the graph database. So what is exactly a Cypher translation example? Well, in a query named find movie, I would ask for a movie in my graph database whose title is The Terminator, and I want a title and a runtime. So those are properties on the movie node. And so in Cypher, I would search for a movie with the match keyword. I would add a where clause on the title property, the Terminator, and then I would return movie title and movie runtime. Okay, so very simple. So it's time for demo, and I will maybe quote some resources before going through the demo. So we have this GitHub repo for the GraphQL library. We have the online documentation on Neo4j website, and there is this npm package for @Neo4j GraphQL library. Okay, so let's switch to the demo. So here I am in the Neo4j workspace. In this workspace, I can define a graph model by adding some nodes here. I can also drag and drop some CSV, JSON, TSV files and import them with no code into the graph database. Here we have an already populated graph database. And you can query the graph database with Cypher code. And if you really want to grasp what is Cypher, I could ask you, hey, what did I draw exactly at the moment? Well, I drew with open parentheses, ending parentheses, closing parentheses. I drew actually a node, a circle. and then with dash dash upper, so I drew an arrow and then another node. So if you understand that, the visual, the ASCII art way of expressing things in Cypher language, then you understand what is Cypher. Cypher is about pattern matching. So you would add a match clause, and I would, for example, search for an air quality index, an air quality index node. So it's a measure of the air quality somewhere in the US. And so I would ask for a relationship, and for example, this AQI was measured. So it's a relationship. I name it R. It was measured at a given location, and so this I could return AQI RL and limit it to 10 results. So here I get an AQI that is located. So I got 10 AQI measured at the same location with a geo point here. And if I were to add another node, I could say that here this is a pass, and I measure an air quality index in a location, and this location is in a given state. And I could return just the pass, limited to 25. And that's it. So I got something like 25 air quality index measures measured at the same location in Alabama, actually. So this is for Cypher queries. Then I could also explore it with no code. I can ask, for example, for the graph model. And here I can see my model. So an AQI is measured in a given year. It's measured at a location, and this location is in a state. Okay. And I could also, for example, try to query my model and say, hey, I would like an AQI that was measured at a location in a state that is Alabama. Okay. And so I can find the 45 occurrences of air quality index measures in a given location in Alabama. So that's it for Neo4j ecosystem with the designing of the model, the import of the data, the queries, and now let's switch to using GraphQL. And so I will share a sample code here of my GraphQL server, which is described in a npm project, in a node project. You have an index.js file with the adequate imports. So I import a .env for my environment variables, Apollo server, Neo4j, GraphQL, the library, Apollo server standalone, Neo4j from Neo4j driver, because I have to query my graph database in JavaScript using the JavaScript driver. And so I define my type definitions. So for example, here I have my air quality index node with an ID, the max air quality index measure, the consecutive days of a good quality index. And there is the relationship with the year node and the relationship with the location nodes, which are defined here, location and state, and also the year. So location is in a state. So I just have to follow my graph model. And then I use my driver. So with my URI, which is using the env file, and then my Neo4j user and Neo4j password. So the driver will be able to connect to Neo4j using those three credential URI, user and password. And then I ask to create a Neo schema from the type definition and from the driver. And it will be spawned in, what was it, the right code? Yeah, I think so. Index.js. Yes, that's it. So I have my terminal here, and I have started. There were a few errors before, but now it's okay. So my server is ready on my computer. So my computer is connecting. So it has a local GraphQL server running, and this server connects remotely to an Aura instance in the cloud. So Aura is the Neo4j solution. So I can connect here to my Apollo server, and then I have a playground, a GraphQL playground that enables me to perform some queries. Here, for example, I ask for 5 air quality index, any of them, and I want the ID, the year, and the location. So this is my sample query and my response in JSON. And each time the GraphQL server connects to the Graph database with the JS driver, and it's totally transparent. So I just have to ask for the payload, and here I can be helped. I can select different things. So for example, I would like to add in the location. Here, I would like to add the states. So with the state ID, okay. And then if I replay my query, I have the state, and it's just following the arrows, the relationships in my underlying databases. So really, the GraphQL data exposition fits perfectly with the underlying graph model in the database.